Alright, I want to find vertical asymptotes. Now, vertical asymptotes are when your denominator equals 0, but there's a little bit more. For a vertical asymptote, what you're looking for, it's when your denominator equals 0 and your numerator is a non-zero value. So you're looking for what spots do you get 0 on the bottom but a non-zero number on top. So what we want to do is we first want to look where does the denominator equal 0. That's the first step. So when does this equal 0? Alright, well hopefully you can see for this you can pull an x out for factoring. That gives you x minus 3 left over. Alright, now to solve this, you're going to set x equal to 0 and x minus 3 equal to 0. And we're going to solve this. This one, when you add 3 over, you get x equals 3. So all that, these are the two spots where you get 0 on the bottom. My next step is to see, well, if I plug in 0, do you get a 0 or non-zero on top? If I plug in 3, what do I get? So watch what happens. What I'm now going to do is I'm going to find f of 0. When I do that, I'm going to get 9 minus 0 squared over 0 squared minus 3 times 0. When I do that, I get 9 over 0. So, does this follow this idea? Yes, it's a number over 0. So what that means is that I have x equals 0 is a vertical asymptote. VA stands for vertical asymptote. Alright, because I have a number over 0 when I plug it in. Let's try 3. Let's see what 3 looks like. Alright, so let's find f of 3. That'd be 9 minus 3 squared over 3 squared minus 3 times 3. Alright, that looks like we get 0, because 9 minus 9 over 9 minus 9. So 0 over 0 is not a non-zero over 0. So what that means is x equals 3 is not a vertical asymptote. Alright, so at 3, what it looks like when you have a 0 over 0, if you think about this, if you were to factor and cancel top and bottom, you would cancel out 3, an x minus 3, top and bottom, thus leaving a removable discontinuity. So usually when you get 0 over 0, a lot of times it's a removable discontinuity. So for this, we have a vertical asymptote here, and most likely a hole at 3.